Hi there. Today we're looking at lesson 2. We're going to talk about circles. You might remember from geometry that a circle, by definition, is the set of all the points x and y in a plane whose distance from a fixed point in the plane is a constant. In other words, that fixed point is going to be the center of our circle. So let's explore by making a few graphic vocabulary examples here. So to get started, this is our chord. This is a chord. And by definition, a chord is a line segment within a circle that touches 2 points on the circle. That's called a chord. It doesn't necessarily have to go through the center. This is our diameter. The diameter does have to pass through the center. And this is our center. And the circumference is the distance around the circle. See if we can write circumference. Is the distance around the outside of the circle. We'll use the second one to finish it up. An arc is, let me draw a couple of lines here to make a sector and an arc. Okay, so we have this section in here is going to be called a sector. It's a pie-shaped piece of the wedge, of a circle. This is the arc from this point here to this point here. That's the measure of the arc. When we go from the center to the outer edge, that's called a radius. And then the pink line down at the bottom, that's going to be our tangent to the circle. And when it comes to circles, you can only be tangent to one point on the circle. But when it comes to a function in calculus, you'll find out that you can have a tangent at one point, but the tangent line can run through the function in another location. But you'll find out about that in calculus. Okay, and the tangent to the circle is going to be 90 degrees. The pink line is the tangent line. So in the next example, you see the Pythagorean relationships. Here's the distance formula in case you've forgotten that. You have your HK is the center of the circle and your radius here. And again, your set of notes would be blank, so you may want to turn them off. And I think one thing's missing, excuse me. You're missing x squared plus y squared equals r squared, which is standard form when your center is at 0, 0 at the origin. So like I said, turn the camera off and complete this on your paper, and then come back to join me when you're done. In our first example, we want to write the equation for a circle whose center is at 5, -2 and whose radius is 6. So using that general form of a circle, x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. Then our job is just to fill in, this is our h, this is our k, and here's our radius r. So x minus 5 quantity squared plus y minus -2 would end up being plus 2, and then 6 squared is 36. This one, example 2, we want to know what the equation for the circle with a radius of 5 and a center that's located on the x-axis where x is -3. That's just telling us that the h is -3, but the k sitting on the x-axis would have to be 0, and the radius is 5. So we'd have x minus -3 quantity squared and y minus 0 quantity squared equals 5 squared. So those are pretty straightforward. You should be fairly familiar with those from geometry. In example 3, we want to do a couple of things. We want to write the equation for a translated circle, x squared plus y squared equals 4. We want to move that circle 3 units to the right and 2 units down. So we're going to move it 3 right and 2 down. That's going to be our HK, or center. And the radius, r squared, is 4. So the radius is 2. So to move that circle, x minus 3 quantity squared plus y minus -2 quantity squared equals r squared, which is 4. And then we want to sketch the original circle. We also want to sketch the translated circle and find the distance between the two centers. So we'll come back here to find the distance, but I believe I've already got them drawn. This is the first one. This is the second one. And they're asking us to find the distance between 0, 0 and 3, -2. So back to our working space. The distance is 3, -2 and 0, 0. So the zeros are going to cancel each other out. 3 minus 0 squared and -2 minus 0 squared is going to be 9 plus 4. So the distance is the square root of 13. This distance here is the square root of 13. So that's pretty easy. In example 4, we want to write the equation of a circle that passes through the point 6, 4 and has a center of 2, 1. So if we know the center is 2, 1, we need to solve for the radius because all we know is the center and one other point, 6, 4. So we could say 6 minus 2 squared plus 4 minus 1 squared would be our radius squared. So 6 minus 2 is 4. 4 squared is 16. And 4 minus 1 squared is 3. And 3 squared is 9. So our radius squared is 25. So we know our radius squared is 25. And we could write the equation for that circle. X, the center, is HK. X minus 2 quantity squared plus y minus 1 quantity squared is equal to r squared, which was 25. And then part B, to write the equation of the line that's tangent to the circle at 6, 4. In this case, we want to know what the slope would be between the 2 points from 2, 1. So let's calculate the slope. First thing we need is the slope between 2, 1 and 6, 4. So the slope is the change in y, 4 minus 1, divided by 6 minus 2. That's 3/4. Then we have to think about, for the slope to be perpendicular to the radius, so think about this. If we're here to here, and this slope is 3/4, then we want the slope here to be perpendicular. That slope that's perpendicular would be -4/3, and it's going to go through the point 6, 4, because this was our point 2, 1. So we're writing the equation for this line here, right, the tangent line. So the tangent line is y minus the y value, which is 4, is equal to the slope, -4/3, times x minus the x value, which is 6. Now you can stop there, or you can distribute the 4/3, and this is what? Add the 4 to the other side. And if you wanted slope-intercept form, 4/3 x, and this would be 3 goes into 6 2 times. 4 times 2 is 8. That would be +8 plus 4. So you could go on from there. So any one of these 3 forms would be appropriate answers for the equation of the tangent line through the point 6, 4. In example 5, we're going to complete the square to get the standard form. So I want to collect the x terms together and complete the square for the x terms, and then get the y terms together and complete the square for the y terms. We'll move the constant 8 to the other side and think about adding the 2 terms that we're going to add to complete the square. So half of 4 is 2. 2 squared is 4. So we want to add a 4 over here to the -8. And then the y squared terms, half of -6 is -3. Squared is 9, so we want to add a 9 to that side. Then factor by grouping x plus 2 squared and y minus 3 squared, and then -8 plus 4 plus 9 is going to be 5. So we have x plus 2 squared, and then y minus 3 quantity squared equals our radius squared of 5. Then in example 6, a couple of challenging circle questions for us here. So if the diameter of a circle contains the points 5, 5, and -3, -1, can we write the equation of the circle in standard form? So there's a couple of ways to go about doing this. If you think about H and K, and visually here I've got some circle, and I've got a point 55 and a point, or I've got a point 55 if I think about it this way, and -3, -1. What I really want to do is add them up and average them to find the middle point. So if you think about it that way, we could say the 5 minus the 3, 5 minus 3, because I'm adding them up and cutting that in half, and then 5 minus 1, add those up and cut it in half. By taking the average, that would give us the center point, HK. So this is going to be 2 over 2, so 1, and 4 over 2 is 2. So we've got, this is our center point at 1, 2. And then the radius, we would want to know the distance between the 2 points. So the distance is the square root of 5 minus -3 squared and 5 minus -1 squared. So we've got what, 8, that's 64, and 6, that's 36. So the square root of 100 is our distance, which makes the distance 10, and the radius is half of that, so the radius is 5. So putting all this together, if this is our center point and this is our radius, then we have x minus 1 quantity squared and y minus 2 quantity squared is r squared. So that was not too challenging, a little bit. Find the equation of the tangent line to the circle. So what was we need our slope, don't we? So our slope would be the change in the 2 points, 5, 5, and -3, -1. So y2 minus y1 over x2 minus x1. That looks like 6/8 or 3/4. So our perpendicular slope is -4/3. That was just like the last one. And we're going to use the y minus k equals m times x minus h. So our y minus k equals the slope times x minus our h, and that's going through the point -3, -1. Now you can move that +1 over to the left and say we've got that. So either one of those formats works. Then we want to sketch the circle and the tangent line we drew. So I'm not sure whether I can do this carefully with my drawing tool, but we'll give it a try. So we want a circle that goes through the point 1, 2. So it's got to go through this point here. And it's got to pass through the point -3, -1. So give that a try here. Okay, so it passes through 5, 5, -3, -1, and its center is at 1, 2. And our tangent line is going to be through this point here. And what I want to check on is this rise over run. So the rise should be 4, 1, 2, 3, 4, and 1, 2, 3 in the negative direction. And then 1, 2, 3, 4, and 1, 2, 3. So I'm a little off. We adjust that just a little bit. So we're going through that point and that point. There. So that looks like we've done it, passing through the point -3, -1, and has a slope of 4/3 in the negative direction. Then our last example is a little more complicated. So we have a circle that contains the points 0, 0, 6, 8, and 7, 7. We want to find the standard form of the equation for the circle by solving a system of 3 equations. So I'm going to use the circle formula. So 0 minus h squared and 0 minus k squared would be r squared for my first equation. That's using this point. Then on to the second equation, we'll have 6 minus h squared and 8 minus k squared would give us a circle. And then the third equation would be 7 minus h squared and 7 minus k squared would give us a circle. So looking at just this first equation, if you expand all of this, we're seeing h squared plus k squared equals r squared. In the second equation, if we expand each of these binomials, that's 36 minus 12h plus h squared plus 64 minus 16k plus k squared. And then in the third equation, we are looking at 49 minus 14h plus h squared plus 49 minus 14k plus k squared is r squared. So we have, these are our 3 equations from the system. So if we just look at equation 2 and equation 3, they're all three equal to r squared. So looking at the 2 and 3, if I collect these terms, 36 and 64, that's 100. And then minus 12h. And what else? Minus 16k. And they both have h squared and k squared in them. So I don't need the h squared on the left and the right. And then in equation 3, we have 49 and 49. So that looks like 98 minus 14h minus 14k. And simplifying that, 98 from 100 is 2, and 12h plus 14h, so that's plus 2h, and negative 16 plus 14 is negative 2k. So dividing those all out, dividing by 2 or factoring out of 2, we have k minus h. Whoop, I wrote it k twice. This should be h. So we got k minus h equals 1. So k is 1 plus h. So I've got a name for k. We can substitute that back into the second equation. So I'm going to substitute 100 minus 12h minus 16k. K was 1 plus h. And that would give us 0, 100, whoop, don't want that color. We want blue. 100 minus 12h minus 16 minus 16h is 0. So 84 is 28h. So if we add that to the other side, then h is, see, 28 goes into 84 3 times. 8 times 3 is 24, 60. Yes, 84. So h is 3, and then we need our k value. Substitute back here. K is 1 plus 3, so k is 4. And that tells me that our center is 3, 4. So x minus 3 squared plus y minus 4 squared is going to be, what's our r? If the center is at 3, 4, that's a 3, 4, 5 triangle. So our r is going to be 25. And you could come back up here to equation 1. If h is 3 and k is 4, then 3 squared plus 4 squared is equal to 25. So our r squared is 25. That one took a little bit of work. But there we are at the end, lesson 2 on circles. See you for lesson 3.